Bismillahirrahmanirrahim. Assalamu alaikum. I am Mrs. Madeeha Farooq, Subject Specialist Chemistry at Divisional Public School and College, Sahiwal. Welcome to the digital classes of DPS. Dear students, you are learning chapter number 3, Gases. Let's have a previous knowledge of the chapter. In this chapter, we have already learned about states of matter. We have learned about properties of gases, properties of liquids, and properties of solids. You learned about gas laws and you learned the detail of Boyle's law. So our today's learning objectives are: what is Charle's law, experimental verification of Charle's law, and derivation of absolute zero. So our today's topic is Charle's law and derivation of absolute zero. At the end of the lecture, you will be able to understand what is Charle's law and what is derivation of absolute zero. Let's see what is Charle's law. For a gas, temperature and volume are directly proportional. If temperature increases, volume also increases. And if temperature decreases, volume also decreases. Gas molecules are in a constant state of motion, and when they are heated, they expand. Let's take a balloon having some gas. When we heat it, its volume increases. As the temperature increases, the volume also increases. You can observe. And when the temperature decreases, by putting some ice under this balloon, the volume is also decreasing. You can see Jacques Charles is credited with this law. Jacques Charles presented his law known as the Charles law, in which he determined the relationship between volume and temperature. According to the Charles law, the volume and temperature are directly proportional. V is directly proportional to T and V is equal to kT, where V is the volume, T is temperature in Kelvin, and K is proportionality constant. V over T is equal to K by rearranging this equation. And you already know that K is proportionality constant. Charles law deals with two conditions, before and after. Let's suppose that before, the volume and temperature are V1 over T1 is equal to K, and after they are V2 over T2 is equal to K. So V1 over T1 is equal to V2 over T2. Let's review the Charles law again. This law was given by French scientist Jacques Charles in 1787, and it is a quantitative relationship between temperature and volume of a gas. Charles observed the relationship between the temperature and volume of a gas by keeping the pressure and number of moles constant. So in this law, the temperature and volume are variables while the pressure and number of moles of a gas are constant. Let's see the statement of the Charles law. According to this law, the volume of the given mass of a gas is directly proportional to the absolute temperature when the pressure is kept constant. अगर हम किसी भी गैस का प्रेशर कांस्टेंट रखते हैं तो उसका जो वॉल्यूम होता है वो डायरेक्टली प्रोपोर्शनल होगा टेम्परेचर के. Let's see mathematically, volume is directly proportional to T. And you already know that V is the volume, This is the symbol of proportionality and T is the constant. In order to remove the symbol of proportionality, we need a constant, and for gases, the constant K is used. So V is equal to KT. Now by rearranging the equation, V over T is equal to K. This is one of the form of the Charles law. Suppose students, if the temperature is changed from T1 to T2, the volume also changes from V1 to V2. Then V1 over T1 will be equal to V2 over T2. So this is the one of the form of the Charles law. V1 over T1 is equal to V2 over T2. The ratio of volume to temperature remains constant for same amount of gas at same pressure. The ratio which you can see between the volume and temperature will always be constant for the gas at same pressure. Dear students, Charles has not only just gave the theoretical explanation of his law, rather he also present the experimental verification of Charles' law. He experimentally proved his law. Let's see the experimental verification of Charles' law. Let's suppose a cylinder and a gas is present in this cylinder. This cylinder is fitted with movable piston. The piston can move up and down depending upon the volume of the gas taken. If the volume taken in this cylinder is V1 and the temperature is T1, then we shall heat this cylinder with the help of a burner. When we heat this cylinder with the help of a burner, the volume increases. So the volume becomes V2 and temperature becomes T2. The experiment shows that V1 over T1 is equal to V2 over T2. Hence, Charles' law is verified that volume is directly proportional to temperature. When temperature increases, the volume also increases. So the Charles' law is verified with the help of the experiment. Now, let's have a recapitulation of experimental verification of Charles' law. This is a volume-temperature relationship. You can observe that as the volume is increasing, the temperature is also increasing. And the ratio of V1 over T1 is equal to V2 over T2 is constant. Now there is example number 2 in your book. Let's see the statement first. What is example number 2? The statement is 250 cubic centimeter of hydrogen is cooled from 127 degrees centigrade to minus 27 degrees centigrade by maintaining the pressure constant. Calculate the new volume of the gas at low temperature. First of all, let's understand the statement. There is a gas which is known as the hydrogen and its volume is 250 cubic centimeter. We cool a gas from 127 degrees centigrade. The initial temperature is 127 and the final temperature is minus 27 degrees centigrade. The pressure is constant. Now we have to calculate the new volume, that is the final volume of the gas. Let's see the solution. The initial volume is 250 cubic centimeter, and if we have to convert it to cubic decimeter, the answer will be 0.25. The initial temperature is T1. It is given 127 degrees centigrade. When we deal with Charles' law, we convert the degree centigrade into Kelvin scale. In order to convert into Kelvin scale, we shall sum up 273. So 127 plus 273 Kelvin is equal to 400 Kelvin. Now the final temperature is minus 27 degrees centigrade. As it is given degree centigrade, we shall convert into Kelvin by sum up 273. The answer is 246 Kelvin. What we have to do, we have to find out the final volume V2. We can find out the final volume according to the Charles' law. V1 over T1 is equal to V2 over T2. By cross multiplication, we can find the value of V2, that is equal to V1 into T2 divided by T1. The V1 is given 0.25, T2 246 is also given, and T1 is 400 Kelvin. The answer will be 0.153 cubic decimeter. And if we may convert into cubic centimeter, the answer is 153 cubic centimeter. So students, you observe that the initial volume was 250 and the final is 153. It confirms the Charle's law that as the temperature decreases, the volume also decreases. That's example number 2. Now there is question in the exercise, question number 5. What is Charle's law? Which scale of temperature is used to verify that V over T is equal to K? Dear students, now you have better understanding about the Charle's law. What is Charle's law? According to this law, the volume of the given mass of a gas is directly proportional to the absolute temperature when the pressure is kept constant. And Kelvin scale is used to verify that V over T is equal to K. Now there is B part of this question number 5 of exercise. Let's solve it. The statement is a sample of carbon monoxide gas occupies 150 ml at 25 degrees centigrade. It is then cooled at constant pressure until it occupies 100 ml. What is the new temperature? We have to find out the new temperature. The V1 is given. V1 is equal to 150 cubic centimeter. V2 is also given 100 cubic centimeter. T1 is also given in the statement. Initial temperature, it is 25 degrees centigrade. As it is given in degrees centigrade, we have to convert into Kelvin by sum of 273. The answer will be 298 Kelvin. The final temperature T2, we have to find it. So the initial volume and final volume is given. Initial temperature is given. We have to find out the new temperature or the final temperature. We can find out by applying the Charle's law. According to the Charle's law, you already know that V1 over T1 is equal to V2 over T2. So by cross multiplication, we can find the value of T2 that will be equal to V2 over V1 multiplied by T1. V2 is 100, V1 is 150 and T1 is 298. The answer is 198.6 Kelvin. So this is the answer in Kelvin. As you know that if we have to convert it to Kelvin, we sum up plus 273 into degree centigrade temperature. But if we have to convert Kelvin scale into degree centigrade scale, then we minus 273 from the Kelvin scale temperature. So temperature in degree centigrade is equal to temperature in Kelvin minus 273. Temperature is Kelvin was now 198.6 minus 273. The answer is minus 74.3 degrees centigrade. So this is the temperature in degree centigrade. Next is question number 6 of exercise. The statement is, what is Kelvin scale of temperature? Plot a graph for 1 mole of a real gas to prove that a gas becomes liquid earlier than minus 273.16 degrees centigrade. And its B part is, throw some light on the factor 1 over 273 in Charle's law. In order to understand this question, you have to understand the topic of derivation of absolute zero. Dear students, in order to derive absolute zero of temperature, consider the quantitative definition of Charle's law. Now consider the quantitative definition of the Charle's law. According to this law, at constant pressure, the volume of the given mass of a gas increases or decreases by 1 over 273 of its original volume at 0 degree centigrade for every 1 degree centigrade rise or fall in temperature respectively. Let's understand this statement first. Students, you know that volume is directly proportional to temperature. If volume increases or decreases, temperature also increases or decreases. If the temperature increases or decreases by 1 degree centigrade, if temperature increases or decreases by 1 degree centigrade, then the increase or decrease in volume will be 1 over 273 of its original volume. अगर हम 1 डिग्री सेंटीग्रेड टेम्परेचर इंक्रीज या डिक्रीज करते हैं तो वॉल्यूम में जो इंक्रीज या डिक्रीज होगा वो उसके ओरिजिनल वॉल्यूम से 1 over 273 होगा. In order to understand the above statement, look at the table. This is a volume temperature data for a given amount of a gas at constant pressure. With the help of this data, we can understand this statement. You can observe from the given data that at 0 degrees centigrade, the volume is 546 cubic centimeter. And when the temperature reaches to 273, the volume becomes 1092. It means the volume has doubled. At 0 degrees centigrade, the volume was 546 and 546 multiplied by 2, the volume has doubled, 1092. And at minus 273 degrees centigrade, the volume has become 0. It practically becomes 0 at minus 273 degrees centigrade. In order to understand it, we need an equation from which we can determine the volume of the gas at various temperature. And we have that equation. The general equation to know the volumes of the gas at various temperature is Vt is equal to V naught into 1 plus T over 273, where Vt is the volume of gas at temperature T, V naught is volume of gas at 0 degree centigrade, small t is the temperature on centigrade or Celsius scale. I hope now you have better understanding about the general equation. This is the equation by utilizing which we can find out the volumes of the gas at various temperature. By using it, we can find the volumes at any temperature. Let's see the temperature volume data for a given amount of a gas again. Student, if a gas is warmed by 1 degree centigrade, it expands by 1 over 273 of its original volume. You can observe that at 0 degree centigrade, the volume is 546. So for 1 degree centigrade rise in temperature, the volume becomes 548 cubic centimeter. For 1 degree centigrade rise in temperature, 2 cubic centimeter increase in volume take place. At 0 it was 546, at 1 it is 548. 2 cubic centimeter increase in volume take place. This 2 cubic centimeter increase in volume is 1 over 273 of the original volume. You can also calculate it by dividing 1 to 273 and multiply by 546. The answer will be 2. It means that the increase in volume is 2. Similarly, for 100 degrees centigrade rise in temperature, at 10 degrees centigrade it was 566, 100 degrees centigrade it is 746. So 200 cubic centimeter change in volume take place on Celsius scale. For example, the increase in temperature from 10 degrees centigrade to 100 degrees centigrade increases the volume from 566 to 746 cubic centimeter. From this table, it is indicating that the volume is not increasing according to the temperature. In order to understand it, let's apply the Charle's law. Charle's law, you already know, V1 over T1 is equal to V2 over T2. When the temperature was 10 degrees centigrade, the volumes become 566. And when the temperature was 100 degrees centigrade, the volume becomes 746 cubic centimeter. Both the sides are not equal to each other. So the two sides of equation are not equal. It means that the Charles law is not being obeyed when temperature is measured on Celsius scale. We have calculated here by applying the Charles law, and it shows that Charles law is not verifying if the temperature is taken in Celsius scale. If temperature is taken in Celsius scale and Charles law is not verified, then what should we do? We need a new temperature scale. So a new temperature scale has been developed. What is the new temperature scale? The new temperature scale is Kelvin scale, or it is also called absolute zero. And this Kelvin scale or absolute zero, it starts from 273 degrees centigrade, more precisely minus 273.16 degrees centigrade, which is called 0 Kelvin or absolute zero. This Kelvin scale is used for applying the Charles law. Let us now explain how the new temperature scale has been developed. The best way is to plot a graph between the variables of Charles law. Let's have the graphical explanation of the variables of Charles law. You already know that the variables of the Charles law are temperature and volume. If we plot a graph between temperature on x-axis and volume on y-axis for 1 mole of an ideal gas, then we get a straight line. This straight line cuts the temperature axis at minus 273.16 degrees centigrade. And this can be possible only if we extraplot the graph up to minus 273.16 degrees centigrade. This temperature is the lowest possible temperature which would have been achieved if substance remained in gaseous state. Actually, all gases are converted into liquids above this temperature. When we further decrease the temperature, then the kinetic energy of the molecule decreases. When kinetic energy of the gas molecule decreases, the molecules come closer to each other and intermolecular forces are developed between their molecules. When the intermolecular forces are developed, then gas starts to convert into liquid or solid phase. So, this temperature minus 273.16 degrees centigrade is the lowest possible temperature which would have been achieved if substance remained in gaseous state. Charles law is obeyed when temperature is taken on Kelvin scale. Let's see the temperature volume data for a given amount of a gas at constant pressure again. You can observe that when temperature is 283 Kelvin, 10 degrees centigrade, the volume is 566 cubic centimeter. While at 373 Kelvin, 100 degrees centigrade, the volume becomes 746 cubic centimeter. Now we shall apply the Charles law at these conditions. So according to Charles law, V1 over T1 is equal to V2 over T2. It's equal to constant K. When the volume was 566 cubic centimeter, the temperature was 283. And when volume was 746, the temperature was 373. They are also equal to 2, which is the constant. So, this proves that V1 over T1 is equal to V2 over T2, which is equal to the constant. Charles law has verified. So, it proved that when we take the Kelvin scale, Charles law is applied. Charles law is only applied when the temperature is taken in Kelvin scale. Greater the mass of the gas taken, greater will be the slope of straight line. Students, we have observed that if we take the mass of the gas in greater quantity, the slope of the straight line will also be greater. What is the reason? The reason is that greater the number of moles, greater the volume occupied. As the number of moles of gases increases, the volume also increases. And if the volume increases, the slope of the straight line also increases. Let's see the graphical explanation again. It is apparent, you can see from this graph, that when we plot between the temperature and volume, straight line is obtained and cuts the temperature axis at minus 273.16 degrees centigrade. This temperature of minus 273.16 will be attained when the volume becomes zero. But for real gases, the zero volume is impossible. कोई भी गैस का वॉल्यूम कभी जीरो नहीं हो सकता if that's a real gas. It shows that this temperature cannot be attained for real gases. This is how we recognize that minus 273.16 degrees centigrade must represent the coldest temperature. So it was about the derivation of absolute zero, how we can derive absolute zero of the temperature. Now there is question number 5 of exercise. Do you think that the volume of any quantity of a gas becomes zero at minus 273.16 degrees centigrade? Is it not against the law of conservation of mass? How do you deduce the idea of absolute zero from this information? Students, we have already learned the general equation to determine the volume of the gas at any temperature, and it is Vt is equal to V naught into 1 plus T over 273. If the temperature is 273, that is minus 273, then we shall apply the value of T. The equation will become Vt is equal to V naught into 1 minus 273. The temperature is 273 divided by 273. When we shall divide 273 over 273, answer is 1. So Vt is equal to V naught into 1 minus 1. 1 minus 1 is equal to 0. When V naught will be multiplied by 0, Vt will be 0. So the volume has become 0. So the first statement has been proved, that the volume of any quantity of a gas becomes zero at minus 273.16 degrees centigrade. But students, you know that any gas does not attain this volume. All the gases become liquid or solid before reaching this temperature. Means one form of matter changes into another form and law of conservation of mass is obeyed. Now let's have a recapitulation of the lesson. First of all, you learn about the Charle's law. How you have better understanding about the Charle's law. What is Charle's law? According to this law, the volume of the given mass of a gas is directly proportional to absolute temperature when the pressure is kept constant. And then you learn the mathematical derivation of the Charle's law. V is directly proportional to T. V is the volume and T is the temperature. They are directly proportional to each other. In order to remove proportionality symbol, we need a constant. And for gases, the constant K is used. So the equation becomes V is equal to KT. By rearranging the equation becomes V over T is equal to K. It was about the Charle's law. And then you learn about the experimental verification of Charle's law. Charles also experimentally verify his law by taking a certain amount of a gas in a cylinder with a movable piston. Its volume is V1 and temperature is T1. Then he heat the gas with the help of a burner, and by heating the temperature increases. As the temperature increases, the volume of the gas also increases. So he proved his law and shows that V1 over T1 is equal to V2 over T2. Hence Charle's law is verified. Next you learn an example of the exercise in which you learn that as the temperature decreases, the volume also decreases. Then you learn the derivation of absolute zero. Absolute zero is the temperature at which the volume of ideal gases becomes 0, and it is equal to minus 273.16 degrees centigrade. Then you learn about the graphical explanation of the variables of Charles' law, that is temperature and volume. And you learn that we have to plot a graph between temperature and volume. Temperature on x-axis and volume on y-axis, a straight line is obtained. This straight line cuts the temperature axis at minus 273.16 degrees centigrade, and this is the lowest possible temperature at which a substance remains in a gaseous phase. Now there is an assignment for you. Question number 1 is, what is Charles' law? You have to define what is Charles' law. Question number 2 is, what is absolute zero? You have to tell what is absolute zero. And question number 3 is, plot a graph between the variables of Charles' law. You have to plot a graph between the variables of Charles' law. It was all about today's lecture. Thank you very much. Have a good day.